Welcome back to Field to Compliance. In today's lesson, we'll connect math with the real world by reviewing the Pythagorean Theorem and learning how to calculate area and perimeter, skills you'll use on job sites, projects, and even everyday problem solving. These aren't just classroom formulas, they're tools you'll use when measuring plots of land, laying foundations, or ensuring environmental boundaries are accurate. The Pythagorean theorem says, in any right triangle, meaning that one angle has 90 degrees, the square of the hypotenuse, that's C, the longest side of your triangle, equals the sum of the squares of the other two sides. It's written as A squared plus B squared equals C squared. Let's try it. If one side is 3 units, and the other side is 4 units, we calculate 3 square plus 4 square equals 3 square is 9 plus 4 square is 16, and 9 and 16 equal 25. The hypotenuse, C, is square root of 25, which is 5. Surveyors, engineers, and environmental professionals use this formula to confirm accurate angles, distances, and slopes. Area measures how much space a shape covers. For rectangles, it's length times width. Let's start with a square. A square is just a special rectangle where all the sides are equal. If each side is 4 units, then the area is 4 times 4, or 16 square units. Here's a rectangle. To find its area, we multiply length times width. This one is 6 units long and 4 units tall, so its area is 6 times 4, which is 24 square units. For triangles, it's 1/2 times base times height. And that's the reason for the triangle formula. The base times the height gives the area of a full rectangle, but a triangle is just half of that. So the formula is 1/2 times base times height. For our example, 1/2 of 4 times 4 equals 8 units. 1/2 times 6 times 4 equals 12 square units. The perimeter is the total distance around a shape. For rectangles, it's 2 times length times width. So for the square, 2 times length times width, which is 16, equals 32. And for the rectangle, the 2 times length times width, which is 6 times 4, equals 48. A 10 by 6 rectangle has a perimeter of 32 feet. Think of it like measuring how much fencing or silt fence you'll need around a site. And to find the perimeter of triangles, you just add up the sides. If you don't have the length of one of the sides, you know how to use the Pythagorean theorem to get that. A squared plus B squared equals C squared. Let's find the length of the hypotenuse, then the perimeter of each. For the triangle on the left, the length of the two sides are given as 9 and 12. So A is 9 and B is 12. Substitute the lengths into the formula, and you get 9 squared plus 12 squared equals C squared. The squares of the sides become 81 plus 144 equals C squared. 81 and 144 give you 225, and you're left with 225 equals C squared. Using your algebra, take the square root of both sides. The square root of 225 is 15. And when you take the square root of any number that is squared, it eliminates the squared portion, and you're left with just that number. So now we have 15 equals C. The length of your hypotenuse here is 15. And to find the perimeter, just add each side. 9 plus 12 plus 15 gives you 36. And for the length of the hypotenuse of the right triangle on the right, it can be found using the Pythagorean theorem as well, because it's also a right triangle. The square root of the hypotenuse is equal to the sum of the squares of the length of the sides. The sides here are 6 and 8, so A is 6 and B is 8. These are substituted into the Pythagorean theorem. 6 squared plus 8 squared equals C squared. The squares of the side lengths are calculated. 36 plus 64 equals C squared. Add the sides. 36 and 64 gives you 100, and you have 100 equals C squared. Use your algebra. The square root of both sides is taken to find the length of the hypotenuse, C. The square root of 100 is 10. 10 is the length of your hypotenuse. And to get the perimeter, just add each side. 6 plus 8 plus 10 gives you 24. Let's talk about two kinds of triangles. An equilateral triangle has all three sides equal, and all three angles are 60 degrees. An isosceles triangle has two sides that are equal, and the base angles are the same. Equilateral triangle has three equal sides. In this example, each side is 6 units. To find the perimeter, we simply add the sides together. 6 plus 6 plus 6, or 3 times the side length, giving us 18. For the area, we use a special formula for an equilateral triangle. The square root of 3 divided by 4 multiplied by the side squared. Substituting 6 for the side, that's square root of 3 over 4 times 36. This simplifies to 9 times the square root of 3, which is about 15.6 square units. And lastly, we have our isosceles triangle with two equal sides of 13 units and a base of 10 units. To find the height, we split the base into two equal parts of 5 units each. That gives us a right triangle with sides of 5, the unknown height, and the hypotenuse of 13. Using the Pythagorean theorem to find the height, given the hypotenuse is 13 units and one side is 5 units, these values are entered into the formula. 5 squared plus b squared equals 13 squared. 5 squared is 25. Then you have b squared equals 13 squared, which is 169. Isolate your unknown. To isolate b, we subtract 5 squared, which is 25, from both sides. We now have b squared equals 169 minus 25, which gives you 144. Now use your algebra to eliminate the squared portion of the unknown b value and take the square root of both sides. If you need an algebra refresher, see Field to Compliance Math Bites playlist or leave a comment at the bottom. Now that we've taken the square root of both sides, we know that b is equal to 12, and that's our length of our unknown side. Now we can calculate the area using the formula 1/2 times base times height. That's 1/2 times 10 times 12, giving 60 square units. The perimeter is found by adding all three sides, 13 plus 13 plus 10, which equals 36 units. Thanks for watching this Field to Compliance Math Bite. I'd love to hear how you use geometry in your own work. Drop your examples in the comments so we can learn from each other. And don't forget to subscribe because our next video dives into trigonometric formulas, another set of tools you will use in the field. See you there.